Mars is not far. At its closest, it is about 54 million kilometers away. A 7-month journey, give or take. That is not the hard part. The hard part is what happens after you land. The hard part is staying alive. This is not a question about rockets or money or political will. This is a question about the human body and whether it can last on a planet that was never built for it. If you are new here, this is Beyond the Cosmos. We go deep on space science, one question at a time. Subscribe so you do not miss what comes next. Before you even set foot on Mars, the journey itself tries to kill you. 7 months in a pressurized can, no gravity. Your bones begin to lose density from the first week. Your muscles shrink. Your heart, no longer fighting gravity to pump blood upward, starts to change shape. Fluid shifts toward your head. Some astronauts return from long missions with permanently altered vision because the pressure in their skulls has pushed against their optic nerves. And that is before we talk about radiation. Earth has a magnetic field. Mars does not. In deep space between the two planets, you are exposed to cosmic rays and solar particle events at levels no hospital on Earth is designed to treat. A round trip to Mars gives you a radiation dose roughly equivalent to sitting inside a CT scanner every 5 to 6 days for the entire journey. Not once, every 5 days. By the time you arrive, your body has already taken a serious hit. Now you have to live there. Step outside without a suit and you are dead in under 2 minutes. The atmosphere on Mars is 95% carbon dioxide. The pressure at the surface is less than 1% of what you feel standing on Earth right now. That is roughly the pressure at 35 kilometers above Earth's surface. Nothing about it is breathable. Any habitat has to maintain its own internal atmosphere. Oxygen generation, carbon dioxide scrubbing, pressure control. Every system has to work, all the time. There is no calling for help if one fails. NASA's MOXIE experiment, which flew on the Perseverance rover, proved it is possible to extract oxygen from the Martian atmosphere. That is a start. But the scale required to support a crew is orders of magnitude beyond what MOXIE demonstrated. And you cannot fix a broken atmospheric system from outside. Every repair, every maintenance task has to happen in a suit, in that air, in those conditions. The atmosphere does not just threaten your lungs, it drives everything. Building materials, energy systems, food production. Mars makes every problem harder. The radiation does not stop when you land. Mars has no global magnetic field. Its thin atmosphere provides almost no shielding. The surface receives radiation at levels that would be classified as dangerous by every standard used on Earth. Long-term exposure increases cancer risk significantly. It can damage DNA over time. It affects cognitive function. And it is invisible, undetectable to your senses, arriving constantly. The current best answer is to live underground. Lava tubes have been identified on Mars. Thick rock, even a few meters of soil, can absorb a significant fraction of that radiation. But that means building your colony underground. Mining, excavating, constructing in an environment with no breathable air, in suits, with heavy equipment that had to travel 54 million kilometers to get there. This is not a problem waiting for a clever idea. The ideas exist. The question is whether the engineering is actually achievable at human scale. There is water on Mars. That is one of the few things working in your favor. Subsurface ice has been confirmed near the poles and at other latitudes. You can extract it, you can melt it, you can drink it, and you can split it into hydrogen and oxygen for fuel and air. Food is more complicated. Martian soil is not like Earth soil. It contains perchlorates, toxic compounds that would kill crops. You cannot simply plant seeds in the ground. Every gram of food has to be grown in controlled environments, with sterilized substrates, artificial light, recycled water, and carefully managed nutrients. The Mars greenhouse concept is not science fiction. Experiments under Mars-like conditions have grown plants successfully. But feeding a colony of even a few dozen people requires a level of agricultural infrastructure that takes years to build and constant energy to run. And calories from plants alone do not cover everything. Protein, fat, micronutrients. A Mars diet would be precise, constrained, and almost nothing like what any human today eats in a normal week. You can survive on it, but it is a system that tolerates almost no failure. You can engineer a solution to air. You can engineer a solution to water. You can build shielding and grow food and maintain pressure. The human mind is harder to engineer around. Studies from the Mars 500 simulation, where 6 volunteers spent 520 days in an isolated habitat, found that crew members developed serious sleep disorders, reduced physical activity, and psychological withdrawal over time. And that was in Moscow, with the ability to leave. On Mars, there is no exit. A light-speed signal from Mars takes between 3 and 22 minutes to reach Earth, depending on orbital position. There is no real-time conversation with anyone back home. No phone call, no instant message. Just a delay that stretches longer the farther the planets drift apart. The psychological selection criteria for Mars colonists may end up being the hardest requirement of all to meet. Every system that keeps you alive on Mars is a system that cannot break without a backup. Power is the foundation. Solar is viable closer to the equator, but dust storms can reduce solar output by up to 99% for weeks at a time. Nuclear power, specifically compact fission reactors, is the serious proposal on the table. NASA has already tested a small fission reactor called kilopower in desert conditions. Water recycling has to approach near-perfect efficiency. On the International Space Station, water recovery runs at about 90 to 93%. Mars will need better. Communication systems have to function despite signal delay, dust interference, and the eventual isolation of a planet out of contact range. Medical equipment has to cover trauma, surgery, chronic illness, dental problems, and psychological crises, without a doctor pipeline from Earth. So, could humans survive on Mars long-term? The science says, possibly, with enormous difficulty, with technology that does not fully exist yet, with psychological demands we have never tested at full duration, and with a margin for error that is close to zero. The honest answer is that we do not know. We have not tried. Every simulation, every analog mission, every rover and orbiter gives us more data. But data is not the same as doing it. What we know for certain is this: Mars does not want you there. The atmosphere, the radiation, the soil, the cold, the distance from help, the silence. None of it bends toward human survival. The question is not whether Mars will ever be habitable in a natural sense. It will not. Not in any human time frame. The question is whether humans can build a bubble of survivability inside a planet that offers nothing for free. The answer to that is not written yet, but the people working on it are not guessing. If you made it this far, you already know this channel does not deal in easy answers. That is the point. Like this video if it made you think. Subscribe if you want more. Drop a comment below with the one Mars survival problem you think is hardest to solve. I read them. Next time, we go somewhere even colder.